Okay. This weekly quiz will become the third and final part of your Test 1 review packet because Test 1 is this Friday. This Friday is September 21st, and as you learned on the first day of school, Test 1 is September 21st, so start studying. I'll be logging on to Moodle, see when people are clicking on the review materials. Hopefully it's not for the first time this Thursday. Okay, I can help you with that. So let's go over this quiz. First of all, use Descartes' rule of signs to count the number of positive real zeros. So I see 1, 2, 3 sign changes. So there. So as far as positive real zeros go, there is 3 or 1 positive real zeros. Then for negative real zeros, negative 2x cubed minus 7x squared minus 7x minus 2. How many sign changes do you see? So there aren't any negative real zeros. That will help you a lot with your guess and check. Okay? Now, here's the interesting thing. Well, first of all, we'll do this the long way. How many possible rational zeros are there? Yeah, the reality is when we create this list, there's going to be 6 numbers, plus or minus 1, plus or minus 2, plus or minus 1/2. But we already know none of the negatives can possibly work, so there's no point in actually plugging them in. Okay? So if any work, which at least one of them must, if I am to solve this whole thing by hand, hopefully it's either 1, 2, or 1/2, or any of them repeated would also be great. So we start synthetic substitution, 3, negative 7, 7, negative 2. So let's plug 1 in. That gives me 2, negative 5. Negative 5 and 7 is 2. 2 and negative 2 is, in fact, 0. So keeping a list of zeros off to the side, 1 works. Then we have a depressed polynomial. It's a quadratic, 2x squared minus 5x plus 2. That factors down to 2x minus 1x minus 2, I think. Yep, that works. So we have the zeros 1/2 and positive 2. Pretty easy. What's that? Yeah, it turned out it was all the possibles repeated once, right? 1, 2, and 1/2. Now here's the interesting thing, and was not expected to have anybody see this, and nobody ever has. But you can actually solve this by factoring. You don't need to use guess and check. But it's not nearly as straightforward as you might think. First of all, what you have to do is rearrange the terms. 2x cubed minus 2 minus 7x squared plus 7x.
Are you allowed to do that? But that's what this is, or I can say that. So it doesn't always have to be in like...
I just said list the possible rational zeros and then find them. I don't care how you find them.
No, but is it when it's in like the... when you have to factor it, so it doesn't have to be in a form where it's like going in like order?
No. No. You can rearrange terms all you want, as long as you're rearranging them legally, right? Commutative property. So, and then we can try factor by grouping. Factor a 2 out, that leaves me with x cubed minus 1. Factor out a negative 7x, that leaves me with an x minus 1. Now, you might look at that and say, well, that didn't work. But x cubed minus 1 is what?
X minus 1.
What's the difference of cubes? That becomes x minus 1, x squared plus x plus 1. Now, what do both of these chunks have in common? So we can factor that x minus 1 out. That leaves me with 2x squared plus x plus 1 minus 7x. If I distribute that 2 and combine like terms, I get 2x squared plus 2x plus 2 minus 7x. That's actually what? Minus 5x. And that factors down to 2x minus 1, x minus 2. Boom. Completely factored it. 1, 2, and 1/2. Is that pretty cool? Yeah. Well, yeah. But that I didn't even know that was possible, actually. Just saw it during second period. Right, how about this one? Descartes' rule of signs. I see two sign changes. So how many positive real zeros could there be? 2 or none. And then for the negative real zeros, we've got positive x to the 4th plus x cubed minus 19x squared plus 11x plus 30. So how many sign changes do you see there? 2 again. So our negative reals, also 2 or 0. So how about our possible rational zeros? Well, we got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, 6, 10, 15, and 30. Okay, so lots of possibilities. I need at least 2 of them to work. So we got 1, negative 19, negative 11, 30. Which one do you want to try first? Anybody remember? 1? Does 1 work? 1 and negative 1 is 0. 0, negative 19 is negative 19. Negative 19, negative 11 is negative 30. Negative 30 and 30 is, in fact, 0. Nice. Negative 5. So we've got 1. Negative 5 and 0 is negative 5. Negative 25 and negative 19. No, sorry. Positive 25 and negative 19 is 6. Negative 30 and 30 is, in fact... Wait, no, that didn't work. Because that gives you negative 60. This is negative 30. Negative 30 plus 30. Negative 3, you say? 1. Negative 3 and 0 is negative 3. Positive 9, negative 19 is negative 10. Positive 30 and negative 30 is, in fact, 0. Nice. So now we have the depressed polynomial, x squared minus 3x minus 10, and that factors down to x minus 5, x plus 2, so it was positive 5 and negative 2 that worked. Okay? Very nice. Then, I thought it was positive 5. Now the imaginary problem is really easy. A subtraction. 3 minus 2 is 1. 5 minus 7 is negative 2. So 1 minus 2i. Foiling here, 2 times 3 is 6. 2 times 7i is plus 14i. Minus 15i. And minus 35i squared. So if we simplify that down, that becomes 6 plus 35 minus 1i. And that simplifies down to 41 minus i. Down here, we're multiplying numbers times its conjugate, so you're going to get 4 minus 12i plus 12i, which will cancel. And then you get your minus 36i squared, and so that becomes 40. Right? Yes? Squiggly what? Oh, yeah, that's fine. Yeah, I'm totally fine with that. And then for number 6, we multiply top and bottom by the conjugate, which is 5 plus I. So the top becomes 15 plus 2i squared plus 10i plus 3i over the bottom, which is 25 plus 1, right? Not yet. So then this becomes 13 plus 13i over 26, which if you wanted, could call that 1/2 plus 1/2 I.
Wait, the test on this week,
Everything. Test. So everything we've learned so far and what we learned this week. So then for number 7, you can just multiply top and bottom by I. That becomes 3i plus 5i squared over 3i squared. We can call that negative 5 plus 3i over negative 3. If you wanted to, you could call that 5/3 minus I. Good stuff? Yay!